Hey everybody, this is Alex Merced from alexmercedcoder.com, and today what I'm going to be doing is doing a lesson on TypeScript, but specifically on object-oriented programming with TypeScript. I was thinking of doing it in JavaScript, but I think actually it'll be a lot clearer in TypeScript. This is going to be one of those times where like TypeScript just helps makes things clearer when you're doing something, especially when you're like typing things and saying, hey, this function's receiving this. Now, the other thing to notice is that if you haven't already subscribed to my Web Dev 101 podcast, but I've also started a new podcast focusing more on data science, data analytics, data engineering called Data Nation, which should also be on wherever you listen to podcasts. So subscribe to both podcasts, Web Dev 101 and Data Nation, and also follow me on Twitter. So if you're a web developer looking for advice on breaking into web development, go follow me on Alex Merced Coder. If you're a data scientist, engineer, analyst, then follow me on AM Data Lakehouse. Cool. But otherwise, let's get started. Cool. So basically what we're going to do is create a new TypeScript file. Okay, so we'll just call this oop.ts. And basically object-oriented programming, the idea here is that we want to abstract things into objects, and basically instead of describe what a object is. So let's pretend that we're making a game where there's two people who are going to fight each other. Okay, so it might be Ken and Ryu who are going to fight each other, but the idea is we're not going to create, we could just create two objects. I mean, that's totally doable. I could be like const Ken equals, and then equals an object, and then name Ken HP. I could do this, but then I'd have to make a whole separate object called Ryu and type this all out again. Rewrite all the methods. That is redundant, especially when they're both going to have the same sort of behavior as far as like how do they attack each other, that they have HP. So in that case, what we do is we try to abstract it. Okay, abstract means, hey, can we create sort of another layer that can simplify things? So Ken and Ryu are essentially both fighters. Okay, so what we can do is we can instead create a blueprint for an object that we want to create called a class. So I just use the word class. We'll call the class fighter, and now I have a class called fighter, and now I can be like, hey, I want there to be a variable called Ken that equals a new fighter. And see, now I'm creating a new object based on this blueprint, which right now has nothing, and saving it in this variable. And I can do the same thing for Ryu. Equals a new fighter. Okay. And the cool thing is I can actually use the class as a way of typing. So I can say, hey, the variable Ken has to be a fighter. So it becomes a type in TypeScript. And I can actually say, hey, these variables need to take in something that is a fighter. Okay, so now I have typed it. Okay, so if I were to assign anything other than a fighter object to this, I would get, TypeScript errors. And let's just console.log them so we can see Ken and Ryu and confirm that they are fighters. Okay, let me open up my terminal. I'm going to be using Deno since I'm using TypeScript. So Deno run oop.ts. And you can see like they're both fighter objects. So you see what happens here is that when you console log an object, it'll console log its type if there is one. Like if it's created from some sort of class, it'll list the name of that class next to the name of the object. That's just sort of how the JavaScript console log behavior is in Node. Now, the thing is that that's still not fun. I mean, remember we mentioned that Ken and Ryu would have a name and HP and stuff like that. Okay, so generally what you want to do is you want to actually sit there and actually add properties to these objects and say, hey, objects, you should have properties. The typical way of doing it is you'll set this all up in a function called the constructor. So you'll literally, inside the brackets for the class, what we'll do is we'll define a function called constructor. It has to be called constructor. Okay, and literally what the constructor function is, so you notice how I'm calling fighter and I'm kind of using the parentheses here as if it's a function. I'm saying, hey, create a new function. No, what I'm doing is that when you use this new keyword, it's saying, hey, create a new object based on this class. The first thing you should do is call this function, then this is just basically the constructor function. So when I say fighter parentheses, I'm really invoking this function called constructor. It's just the way it works. You're going to find this to be similar in pretty much every programming language. So in this case, what I can do is inside here, I can define properties of the object. Now, I don't know that how many objects I'm going to create. All I know is that this function is going to run to create an individual object. So there's a keyword to refer to the object that's currently being created, and that's this. Okay, so whenever I say this, in the context of when I call fighter here, this is going to be this Ken object. When I call fighter here, this is going to refer to Ryu. Okay, so this always refers to that object. Okay, in JavaScript, it gets a little bit more complicated, of course, because this is really referring to the object that invokes the method. But if you're using classes, at least at this stage, it shouldn't that distinction shouldn't really matter. It does matter when you start getting into DOM manipulation and how this keyword can interact with like a method being triggered by a button click or something like that. Because you click the button, then this becomes the button, and it causes all sorts of confusion. Although I would say most front-end frameworks have abstracted that issue away. So generally not as much of an issue as it used to be. Okay, but bottom line is this. Just again, the behavior. Whenever I say the new keyword with the name of a class after it, then again, I'm invoking the class, because really what I'm doing is I'm invoking the constructor function. What's happening here is I'm really calling the constructor function. This function allows us to set up any initial properties in that object, and then the resulting object gets saved over here. Okay, so that's essentially what's going to happen here. So we're going to say, hey, we want there to be this.name. The problem is, I mean, I could give it a static name, so I could sit there and say Ken. Okay. Okay, now notice it doesn't like how I define fighter, because I haven't defined what a fighter is. Okay, so in Typescript, you actually have to declare the properties ahead of time. So I'd have to be like name string. You don't have to do that in JavaScript. Okay, so I'm declaring the property here so it knows which properties exist, and then I can define them here. So I'm saying, hey, this class should have a property called string. Okay, a property called name, which is a string, and then you see that's all good there. Problem with this is by hard coding the word Ken, see now they're both named Ken. One should be Ken, one should be Ryu. So how do I make it dynamic? Again, we have this constructor function. It's just a function like any other function, so I can define parameters to receive arguments. So we'll say, hey, every time you use this constructor function, we want to receive a name, which should be a string. Okay, and now what I can do is instead of saying this.name equals the name that gets passed into the function. But now I'm getting these errors because it's not getting the arguments that it's expecting. So I'm going to go in here and say, hey, Ken, and then over here say Ryu. Okay, and again, this is technically a little bit more succinct than me writing just two full objects. And again, as we add more properties, you'll see that this gets a lot easier than writing just like the two objects individually and just rewriting the same thing 2 times. Okay, and see I have new 2 fighter objects that have the name Ryu. Now again, these are also going to have like HP, because they're going to have hit points, which will be a number. We're going to have a life, which will also be a number. Okay, and then they're both gonna start with a life of 20. That's gonna be a fixed. So we can start that there. Because if it's fixed, you can just actually define the initial value here. So, but the HP, actually HP will be, oh, well, HP is life. I meant this should be strength. Okay, and then this should be 20. Strength. Okay, how do I want to define strength? I don't want to let the user define the strength, so we're going to have that become a random number. So we'll say this.strength equals math.floor, because we're going to run down. Then we're going to use math.random to generate a random number between 0 and 1. and then we're going to multiply that by 5. Okay, and that's going to give us a number between 0 and 5, and then we're going to make sure that's at least that's at least 1. So we're going to add 1 to it. Okay, so that's going to do is figure out the random number between 0 and, really it's going to end up being between like 0 and 4, and basically add 1 to it. So that way if you get 0, you still have at least 1 strength. Okay, there we go. So now if I run this, I can see, look, this time Ken has 3 strength. This time Ryu has 1 strength. And now if I run this again, it should be random. Okay, and see now Ryu is stronger in this role. Okay, and this is kind of how you can create sort of like random stats for like a game. Cool. So now I want these fighters to be able to attack each other. Okay, so they should have a function, a method, because attacking, whenever you're abstracting something into an object, there's the properties, there's the things that describe it. So how do I describe a fighter? Name, HP, strength. That's how I'm describing it. Okay, so just think like, what is a fighter? What are its properties? Now, what are the things that a fighter does? They're going to attack. So in that case, that's a function, also known as a method. So anytime that thing you're abstracting into a class does something, that should be a method. So in that case, we're going to have a method called attack. And essentially what we're going to do is you're going to attack your opponent. So we're going to have target, the target who you're attacking, which should be another fighter object. So, and again, this is where using Typescript is going to make things a little bit clearer, because now we know, okay, hey, whenever I refer to this target variable, it's assuming another fighter object. So it's going to have all the same properties and methods of any fighter object. Okay. So what's going to happen here is we'll console.log. Okay, so the assumption here is that this fighter is attacking the target. So we're going to use backtick, so we can use like interpolation. So we're going to say this.name to refer to this fighter, this.name attacks target.name, because again, target is a fighter object, so it has a name property. I mean, I don't know which fighter object it is. That's the beauty of it. We don't need to know that. We just need to know that a fighter object has certain properties. That's the beauty of typing. It just helps us latch onto that a little bit more. We know what a fighter is because we're defining it. Okay, target.name. And does, we'll keep this simple, does this dot strength damage. Okay, cool. And then basically what's going to happen is we're going to say target dot HP minus equals, because we're reducing the number, so we're subtracting and then reassigning the result of that to the variable, minus equals this dot strength. Okay, and there we go. Now they can attack each other. So technically now I have 2 fighters. They can attack each other and life's all good. And I can make this more complicated. I like defense, do probabilities of being able to make a hit. But let's just show you how like this would look like as a game. So now I created my 2 fighters. Now I want to write like a while loop. I'll just say while true, because generally games are going to be infinite loops. They're loops until you decide to quit. So the quit would break the loop. In this case, the loop will break when one of them dies. So what we're going to do is at the beginning of each loop, we're going to check if can.hp. So now I'm referring to the object by the variable that I have the object stored in. So no longer this, because I'm not defining it. It's not the blueprint anymore. If can.hp is greater than 0, it's actually, no, actually equal or less than 0. Okay. Expression expected. Just complaining that I don't have this. Yeah. Okay, so less than or equal than 0. Then what I'm going to want to do is say, if Ken's HP is less than 0. Actually, I would want to do this after each attack. So basically, first what we'll do is we'll do Ryu will attack Ken. dot attack, and then again we're going to pass in Ken because Ken's a fighter object, so that satisfies the type. Okay, I'm supposed to pass a fighter object to this function because that's how we defined it. We say, hey, this receives one argument, which is a fighter. So I say Ryu attacks Ken. And then if Ken's HP is less than or equal to 0, we'll just say console.log Ken loses, and then we'll break the loop. Okay, and then we'll just do the same thing for the opposite situation. So let's just say Ken attacks Ryu because he Kens the object and has the method attack, and then I pass it Ryu as the argument. And then we'll also say, hey, if Ryu's HP is 0 or less, then Ken loses, and then that's it. That's it. That should theoretically work. Okay, so let's run that. Hopefully I don't run into a infinite loop. Then I'll run. Yep, and it worked. Okay, so you can see here the battle worked out. Ryu attacks Ken, does 1 damage. Ryu attacks. Then they just keep fighting each other until Ken gets defeated. Okay, and that's it. That's basically the basic gist of object-oriented programming. Like, of course, there's other things we can do. Like, we want to create other types of fighters, but we don't want to have to put everything inside a fighter class. You could do what's called inheritance, and I could do something like class, sword fighter. Okay, and then I would just say like extends fighter. And then basically what that's going to do is going to give me everything that's already here, but then I can add like additional methods or, add additional stuff. Okay, so if I want to add additional functions, I can do it here, and then instead create a sword fighter instead of a fighter. So I can be like, okay, hey, Ken's going to be a sword fighter. Okay, and there we go. And notice like it still is okay with me creating that because even though this says type fighter, this sword fighter class inherits from fighter, so it should still have all the same properties and methods, so it satisfies the type. But yeah, I'll leave it at that. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.